Hey everyone, welcome to a new series. This is called Experiments in AI. So before I get on to this first episode, I'll just explain a little bit of how I came to this, because it's a saga now. So let us go into the story. So yeah, Experiments in AI, that's going to be a new series. This episode I'm going to look at comparing models in Ollama. And yeah, I have managed to put this together. I don't know if anybody saw the post this morning, but I was trying to do some research and development for this series, and a certain assistant of mine had other ideas. So I started off on the kitchen table just brainstorming a few ideas, and Mav came along and wanted to add his own thoughts on the matter. And then I went to sit on the sofa, and then he joined me there. This is actually the treat where the treats are stored for convenience. So clearly he was angling for some treats. And then after I gave him a treat and then proceeded to ignore him a little bit, he went around the back and started playing with my cables. So we reconvened to the downstairs office, and he actually sat quietly in the other chair for quite a while, although he's disappeared off somewhere now. No doubt he's up to some mischief somewhere. And this sort of grew out of this series. What had happened with this is that the gentler introduction, originally I'd intended on doing lots of different technology, but as you've noticed, it went on a bit of a LLM jag. The first episode was about the factor programming language, which did prove pretty popular relative to other viewing figures on my channel. But then I went into a bit of a exploratory coding stroke LLM riff. And after I did several of them, I thought, well, I've sort of deviated a bit, because what had happened was they were really turning into experiments. And each one was a sort of gentler introduction to experimenting on similar things. So some were looking at using Google Gemini Studio, for instance, example. Other ones were using Ollama. Other ones still were using Hugging Face as well. So I thought, well, why not create a separate series where I just do experiments to do with LLMs and AI and machine learning, and have that as its own thing. And then with this series, a gentle introduction, I can go back to what it was originally about, which is trying to introduce people to maybe technologies, programming languages that maybe they haven't seen before, or maybe they're trying to learn at college and it's not going so well, those sort of things. And so the idea is to maybe only cover something once as an introduction and not do what I ended up doing, which is looking at the essentially similar things through lots of different lenses. So I've sort of bookended that. This will carry on, but hopefully I'll get back to doing various technologies that I've stumbled across during the week. So what do you need if you want to, experiment along with me? So this is what I'm using. There's other tool chains that will do a similar thing, but this is what I use. So this is what I'm going to recommend. So I use Anaconda, as I've said in multiple episodes, because it has all the stuff, all the tool chain components I like to use when I'm working with Python. And we're going to be working in Python, specifically Python notebooks for this series, although occasionally I might decide to look at interacting with AI models and machine learning stuff using different languages. I'm particularly interested in seeing things like stuff that runs on the beam, for instance. So yeah, that's going to come in the future. So this is the one that I've got. Running a Windows machine. I just installed this. It's good to go. And for this episode, we're just going to be using some libraries from it, which you'll see in a moment. I've also imported a library already, pip installed it, shall I say, and we're going to be importing it to use it. So we'll need that as well. But this is always my sort of first step, and any machine I want to do this is to install Anaconda. You could get away with Miniconda. You also need to download Ollama itself. That's pretty easy to download and install. I've looked at that in previous gentle introduction episodes. And I will also be doing there'll be some libraries we need to install. Now you could go in and, fire up a command prompt. So Ollama's already been installed and running, and download either through running or pulling the model that you want, the models you want to use. That would be one way. The way I've got it designed here, and you'll see in a moment, is the code actually pulls models that it needs. And once they're pulled, if it tries to pull them again, it already knows they're there in Ollama, and so doesn't. And you'll see how that works in the code. So everything's been pre-pulled because I've run this several times already. I've got another number of other models that I'm not going to be using, but if you just wanted to see what the full list is, there we go. So you need Ollama, need some libraries, but the code will pull down the ones you need for that. And you'll also need to install the Ollama Python library, because it's not part of Anaconda. Some of the other stuff we are using is already part of, included in the Anaconda install. In fact, probably included in most Python distributions, most Python tool chains. But certainly, if you haven't already pip installed the Ollama Python library, then yeah, you will need to do that. You can do that at a command prompt. Anaconda has command prompts, which you can do that in. We can do it at a regular command prompt. But also you can do it within a Jupyter Notebook as well. And here's the Jupyter Notebook. I'm going to be posting this to my GitHub. So in this episode, we're going to be looking at some experiments to do with, I suppose, personalities and styles, but really determined through the prompt. So we're not doing any system shenanigans, anything like that. We are purely implying, so it's, what would you call it, implicit, I suppose, in the way the question's structured. Some of it is explicit, like that, but it's all gleaned by the model from the prompt. So we're doing a sort of personality and style comparison between 4 different models. In other episodes, I'm going to look at things like prompt engineering techniques, to do with zero shot versus few shot versus chain of thought. Code generation, debugging, so looking at specific models that might be better for that, and playing around with translations to languages, looking at model files, which I think is really important, so how to customize those. So there'll be an episode on that. Multimodal models, playing around with those, benchmarking, retrieval, augmented generation, RAG stuff, reasoning and logic stuff, writing, creative writing, which some of this is sort of doing, but maybe diving a little bit deeper into creative writing features in large language models. And then a little bit about using the Ollama API again. So I know I did a an episode of the gender introduction where I sort of looked at that and how to sort of roll your sleeves up and really get under the bonnet with JSON requests and parsing JSON. For this episode, we're sort of leaning into the Ollama library, which allows us to abstract away all of the sort of JSON and request unpresentness that you normally have to sort of wrestle with. So that's one of the advantages of using this library. But in a later episode, I would like to sort of take a look at maybe, how you do it just using regular requests in the JSON library versus how you can do it through the Ollama library. But in this episode, it really is just the Ollama library. The only reason why I've got to import JSON for this is because we're doing some JSON shenanigans at the end in terms of just to make saving the results nice and easy for us for potential future use. And then probably I might get onto some more advanced stuff in later episodes. So maybe some pipeline stuff, tool using, what else? Structured data extraction, that sort of thing, hallucinations, multimodal complex tasks, just to see. So it's going to work out. So I'll probably put out at least one of these a week. And what I'm going to do is obviously spend that week experimenting, and then what you see here will be the results of my experiments with or without the help of Mav, depending on how he's feeling, so, and where he is. Anyway, so let's go through this. So let's first of all just import everything. As I said, all this stuff is either battery included in the install, or in the case of Ollama, I've already installed it. So these are the 4 models that I'm going to work with, and you'll see in a moment how they get pulled down. This is the prompt we're going to work with in this, and I've made this so that all you need to do is, if you want to try a different prompt or create your own prompt, you just need to comment, uncomment these, add extra ones, do whatever you want to do. You could put this itself in a loop. We're going to be iterating through the models, so you could do an iteration inside an iteration. So you could iterate through the prompts and then iterate through the model, each model for each prompt, do that. But for this one, we're not going to do that. But you could modify the code to do that. So number of functions. First function runs a prompt against a specific Ollama model, returns a response, does some very basic error handling, nothing too taxing. Also works out a response time, also a generation time, and this is doing it in code. You can pull the information down from the response itself, I think. The trouble is I've worked in so many different model APIs now. I get confused in terms of which ones have which pieces of information, but I'm pretty sure Ollama in the JSON response has a key value pair which has the various timings on the model response. But we're going to do this ourselves by taking the time before we send the response and taking the time after it comes back. So that way we get a response time which is more appropriate to the environment it's actually being used in. So it'll take into account any other factors that are getting in the way of the response time, if you like. There's our reference to our key value pair. So we just want the response part of the JSON response. And rather handily, as I've said, the generate function from the Ollama library in this case is taking care and abstracting away all of that API interaction unpleasantness, which I enjoy, but some people don't. So it's fun to be able to abstract that away it just takes in the model and it takes in the prompt. You can take in other stuff as well, but in this instance, we're just providing it with those arguments, but there's other arguments you can provide it with. So yeah, that response, just going to strip it out. We don't have to, I suppose, but yeah, might as well. Calculate the generation time, which is just the start time, the end time minus the start time. Also return none if we get an error. And we've got an exception catch as well. I'm sorry, returning none, because we don't mean returning none if we get an error. But we're not going to be getting an error if this works. If we do get an error, then the contents of the return is going to be slightly different, because we won't be getting any response text back, we won't be getting any generation time back, but we will be getting an error message, which we've captured. We'll also be printing the error message as well. You can see there's a number of sort of not so much debugging prints, but just prints that let us know what the hell's going on sometimes. This is the pull model function. So yeah, again, nicely abstracted away. So it just goes away, talks to Ollama as part of the abstraction in the Ollama library. It knows not to pull it from the internet if the model's already present in Ollama. It's all part of the function. So that's nice. We haven't got to mess about with any of that. I think even if we were to use request with the appropriate pull endpoint, there's certain things that I think can take care for us, but you could do some other things with checking what the model list is and see if your model's in there, that sort of thing. But we don't need to do that because the library's doing all the heavy lifting. Just a little print there to say, yep, it's either been pulled or it already exists. If we get an error, we get an error to say if there's a problem pulling the model for whatever reason. Maybe we got the name wrong. Maybe it couldn't pull, couldn't pull the model because it was the wrong name. Very, very crude analysis here. This probably potentially could generate some interesting logic errors, or not a logic, what would you call them? Like just inaccuracies, should I say? But it's just for the process of illustration. We're just splitting up the response, counting the number of words by doing that. So getting the length of our split. If we don't get any response, it's just going to return zeros. We've got a very crude sentence count that's really just counting the full stops, the exclamation marks or the question marks. So the sort of thing that will be used at the end of sentence. Very unsophisticated, and you could probably see where we might run into problems with certain data that's coming back. But just for the process of, putting this code together and playing around with a few concepts, it's sufficient for that. And as I've mentioned here, you can do some much clever stuff with NLP libraries. I'm trying to remember the one. It's NT something. I can't remember the exact. I've used it before. I don't think I ever used it in an episode that went out. I was playing around with a similar concept in possibly Hugging Face, maybe, and I don't think I got around to recording that because I decided to sort of concentrate mainly on Ollama stuff. So I don't think that ever went out, or ever recorded it. But I know I've dabbled around with doing slightly more elaborate analysis. There's also some stuff you can pull down from the JSON response in terms of like tokens, I think, those sort of things as well. So you might want to look into that. Got some stuff here obviously to avoid any divide by zero unpleasantness, and it's going to return the word count and the complexity. Then we got a big chunk function here. This could probably be chunked down into various functions and helper functions. It's essentially doing pretty much all the comparison against the models the gathering in the results and printing the comparison in one function, but you could split this down further. So we're going to just create a list of results, because we're going to just store everything temporarily just in this results variable, this results object, and then we're going to do some stuff with it after the fact rather than just print it straight out, which we're going to do, but we're not going to just do that. So we're going to iterate through the models. Ta-da! There we go. And what are we going to do first? We're going to pull them, or try to. And what we will do is, let's run actually everything while I'm talking about the rest of this. So I'm going to run selected cell and below. There we go. So when we get to the bottom, you can see what's going on here, but I'll walk through that in a moment. I just want to do it to do some of the comparisons. Okay, so yeah, we're iterating through the models. We're going to do a pull request using our function. If there's an error pulling the model, then it just says I'm skipping the model due to an error. Now there's a bit of belt and braces going here, because if you remember, we'd already pre-screened the models to make sure there wasn't anything in there that probably didn't exist. Oh no, actually, sorry, I'm jumping ahead of myself, aren't I? It's all right, I've already shot this video once, so yeah, I'm thinking about something I said earlier. Sorry, no, this bit here does that. Actually, it'll pull, so it'll try and pull the model, and it will update the models list if it finds a model that it can't pull. Yeah. Then we're gonna, once we have that list, we're gonna iterate through that refined list if indeed it did get refined. But whatever we do, it's going to be the models list after it's been through this pull process. Okay, so it's going to run the prompt, because it's the same prompt over and over again, so there's only one prompt to run. So we don't need that in a loop, but we want to loop back, iterate back through the models. So we're going to run a prompt with the following model. We're going to run the Ollama prompt with the model and the prompt, but also capture any errors as well. So we've got the response, the generation time, and the error coming back from our previously defined function. If response is not true, I'm sorry, it's not true. So if the response is not none, so if we have actually indeed got a response back, then it's going to start creating this key value pair dictionary with prompt, response, word counts, complexity, generation time, and error for our model. So it's iterating through each model and creating this results list, and in that list is a series of key value pairs for each model in the list. If there is a problem, so if the response happens to be none, then it's still going to know what the prompt is, and it's still going to know what the generation time is, but there's going to be no response, word count, complexity, and there's going to be an error. So it loads up the key value pairs with the appropriate things based on the fact that there's no response. Then, just for the interests of us sort of seeing what's going on, it is going to print out a comparison of model outputs. So it's just going to literally iterate through the results when we get them, just so we can see what we've got. In there. And it's going to return that results dictionary, which includes the error as a return. So it's sort of printing everything out as part of the function, but then returning that results dictionary, including any errors if there are any. Again, we could do this slightly differently as well. We could put this in its own function, maybe not even show it. Don't have to. And then finally, it's going to print out some stuff that's going to keep us up to date with what's going on. So it'll just prompt us to say, yeah, there's a model pull prompt and response comparison going on. It's going to do that and then call all the appropriate functions and helper functions and whatever. And then the final bit of the puzzle is it's actually going to save the results to both the JSON file and also to a MD file as well, a markdown file with the appropriate structure. Again, so pretty crude ways of doing this, and I'm sure people could do more inventive things. Got a bit of indentation shenanigans going on as well to make the JSON dump a little bit more readable in there. This is where our sort of JSON library comes in. The only reason why we need to use it here. We've also made sure that our file names, which is just model comparison results, includes a timestamp so that if we're doing multiple ones of these, we don't accidentally overwrite the previous one if we want to run another set of these. And there's the bit that does the MD file. And you can see here we've got this, then it'll go through, and this would have generated pretty quickly. So it goes away, tries to pull the model. If the model doesn't exist in the Ollama database, in the local Ollama list instance, then it will pull it. So it'll take a bit of time doing that before it goes on to the next pull and the next pull. This time I'm going to run pretty quick because all of these have already been pulled, downloaded. There's our prompt, and then each one of these would have come up as the prompt would have been run through the model, each of the models. And there's just the comparison of model outputs, so we can sort of eyeball it when we're doing this if we wanted to. And you can see, for this one where we asked it, what was it? Tell me a short story about a lost cat finding its way home. So there's the Llama 3.1 version, the Mistral, the Gemma 3, and then finally the Quen 2.5. And each one you can see is also prints out the word count, the average words per sentence, and the number of seconds that it took to complete. And the fact that it saved the model to a certain couple of files. So this is what the files look like. Let me bring these up. Okay. So this is the JSON source file. There you go. You can see what that looks like. So this is useful if we ever want to sort of do an additional processing. We don't have to sort of rerun the model query again. It's there, we've got what we asked it, what the response was, and then the word count and various other things. So yeah, easy to repeat. Any additional analysis we want to do on the response without having to re-interrogate or do a request to the models and then probably get a different answer. You can do, if you see me do other episodes, you can do some clever random number generation stuff where you can get the same result back from the model every time. But yeah, we're doing this slightly different by saving the result, so we've got this ready to go. The other thing you saw me do was the MD version. It's not great. You know, there's some stuff here which contravenes the MD rules, but I just wanted something a bit more user-friendly to read. If I wanted to read through this rather than the JSON file. So you see we've got the model, the prompt. Now it is repeating the prompt every time here, so we don't have to keep going to the top and saying, what was the prompt? Even though it's the same one. There's the model, the prompt, the response, the word count, the complexity, and the generation time. You'll notice, not surprising, the JSON file, it's not adding this in, because if we're trying to then at a later date pull out this data, we don't want any additional text sort of interfering with it. So that's why it's in the MD file, because this is more for just readability, whereas this is for, you know, being able to pull data out of a dictionary. And there we have it. So have fun. Let me know in the comments section how you get on, if it's something you like playing around with. I'll upload this obviously to my GitHub, include a link in the description, and I look forward to showing you the next experiment whenever I get around to doing that, which will probably be prompt engineering techniques. Zero shot, few shot, and chain of thought. Oh, that's going to be interesting. Yeah, and just again, ways in which we can say, okay, how do those examples improve the accuracy? Does step-by-step model, you know, improve the reasoning or problem solving, where we're not using necessarily a reasoning model specifically? And again, you can do some interesting stuff here. You can sub this out with your own models, because this is designed, if you've got Ollama on the system, providing you've got enough space to pull down the model if it's not there. The only thing you have to remember, if you run it, it's going to take a bit longer when you do that first pull, but you can see it doing it as it goes along, so it's informing you. But you could put smaller models in here. You could include thinking models. You could use mixture of expert stuff, you know, knock yourself out. But I just wanted a nice, easy way to be able to do that. So thanks once again for watching. Bye for now, and I will catch you in a future episode.